Planet Earth, a world of breathtaking beauty and awe-inspiring power. From the towering heights of mountains to the depths of the oceans, nature's forces shape our world. Among these forces are some of the most destructive phenomena known to man: tornadoes, typhoons, and hurricanes. These swirling tempests of wind and rain can unleash unimaginable chaos, leaving a trail of destruction in their wake. Understanding these storms, their differences, and their potential for devastation is crucial for those who live in their paths. This knowledge empowers us to prepare, to protect ourselves, and to rebuild when the storm has passed. In this exploration, we will delve into the heart of these storms, unraveling their mysteries and revealing the awesome power they possess. Join us as we journey into the eye of the storm. Before we can understand the differences between these three types of storms, we must first define what makes each one unique. Each storm has its own characteristics, behaviors, and impacts, which are crucial to comprehend for both meteorologists and the general public. By understanding these differences, we can better prepare for and respond to these natural phenomena. Though they share some similarities, their formation, location, and behavior set them apart. Tornadoes, hurricanes, and typhoons each have distinct features that make them unique. For instance, the conditions required for their formation vary significantly, as do the regions where they are most commonly found. Tornadoes, the most localized of the three, are violently rotating columns of air that extend from a thunderstorm to the ground. These powerful wind funnels can cause immense destruction in a very short amount of time, often leaving a narrow but devastating path of damage. They are most commonly found in the central United States, an area famously known as Tornado Alley. Their telltale funnel shape, often compared to a giant vacuum cleaner, is a harbinger of destruction. The sheer force of a tornado can uproot trees, demolish buildings, and hurl vehicles through the air. Despite their relatively small size compared to hurricanes and typhoons, tornadoes are incredibly dangerous and can form with little warning. Hurricanes and typhoons, on the other hand, are massive swirling storms that form over warm ocean waters. These colossal systems can span hundreds of miles and last for days or even weeks. They are fueled by the heat and moisture from the ocean, which gives them the energy to grow and sustain their powerful winds and heavy rains. These behemoths can span hundreds of miles, bringing with them high winds, torrential rain, and the threat of devastating storm surges. When they make landfall, the impact can be catastrophic, causing widespread flooding, property damage, and loss of life. Coastal areas are particularly vulnerable to these storms, and the aftermath can take years to recover from. While hurricanes and typhoons are essentially the same phenomenon, the terms we use to describe them depend on their location. This distinction is important for understanding global weather patterns and for communicating the risks associated with these storms to different regions of the world. In the Atlantic and northeastern Pacific, they are called hurricanes, while in the northwestern Pacific, they are known as typhoons. This naming convention helps meteorologists and the public differentiate between the storms based on their geographic origin, even though their characteristics and impacts are largely the same. Regardless of their name, these powerful storms demand our respect and caution. Preparation and awareness are key to minimizing their impact. Communities in storm-prone areas must have plans in place to protect lives and property, and individuals should stay informed about weather conditions and heed warnings from authorities. By understanding the nature of these storms, we can better prepare for their arrival and mitigate their destructive potential. The formation of these storms is a complex dance of atmospheric conditions, each one playing a vital role in the birth of a tempest. From the initial gathering of clouds to the eventual unleashing of powerful winds and rain, every step in this process is a testament to the intricate balance of nature. The atmosphere, with its layers and varying temperatures, sets the stage for these dramatic events. As we delve deeper into the mechanics of storm formation, we begin to appreciate the delicate interplay of forces that drive these natural phenomena. Tornadoes, often associated with severe thunderstorms, are born from the clash of warm, moist air colliding with cold, dry air. This collision is not just a simple meeting of different air masses. It is a dynamic interaction that can lead to some of the most violent weather on Earth. The warm, moist air rises rapidly while the cold, dry air descends, creating a turbulent environment ripe for storm development. This process can be observed in various parts of the world, each with its unique characteristics and intensity. This collision creates instability in the atmosphere, leading to the formation of powerful updrafts and downdrafts within the thunderstorm. These vertical movements of air are crucial in the development of severe weather. Updrafts carry warm, moist air upwards, where it cools and condenses, forming towering cumulonimbus clouds. Downdrafts, on the other hand, bring cooler air down to the surface, often accompanied by heavy rain and strong winds. The interaction between these updrafts and downdrafts can lead to the formation of hail, lightning, and even tornadoes. As these updrafts and downdrafts intensify, they can begin to rotate, eventually forming the tight, spinning vortex we know as a tornado. This rotation is often initiated by wind shear, which is a change in wind speed and direction with height. When conditions are just right, the rotating updraft, known as a mesocyclone, can tighten and stretch, leading to the formation of a tornado. These tornadoes can vary greatly in size and strength, from small, short-lived funnels to massive, long-lasting twisters that can cause widespread devastation. Hurricanes and typhoons, unlike their land-based counterparts, require warm ocean water to form. The vast expanse of the ocean provides the necessary heat and moisture to fuel these powerful storms. As the sun heats the ocean's surface, water evaporates, adding moisture to the air above. This warm, moist air is the lifeblood of tropical cyclones, providing the energy needed to sustain their growth and development. As warm, moist air rises from the ocean's surface, it creates an area of low pressure below. This low pressure area is a critical component in the formation of tropical cyclones. The rising air cools and condenses, releasing latent heat, which further fuels the storm. This process creates a positive feedback loop, where the storm continues to draw in more warm, moist air, strengthening and growing in size. This low pressure draws in more air, creating a cycle of rising air and converging winds. The Coriolis effect, due to the Earth's rotation, causes the converging winds to spiral, giving the storm its characteristic rotation. As the storm system organizes, it develops a well-defined center, known as the eye, surrounded by a wall of intense thunderstorms. The eye is often calm, with clear skies, while the eye wall is where the most severe weather occurs, with strong winds and heavy rain. As the system spins faster and faster, it gathers strength, eventually developing into a tropical depression, then a tropical storm. The classification of these storms depends on their wind speeds, with tropical depressions having the lowest wind speeds and hurricanes or typhoons having the highest. The transition from a tropical depression to a tropical storm marks a significant increase in the storm's intensity and potential for damage. And finally, a full-fledged hurricane or typhoon. These powerful storms can span hundreds of miles and last for days, bringing torrential rain, strong winds, and storm surges that can cause significant flooding and damage. The impact of these storms can be devastating, affecting millions of people and causing billions of dollars in damage. These storms, though destructive, are a testament to the incredible power of nature and the complex interplay of forces that shape our planet. Understanding the formation and behavior of these storms is crucial for predicting their impact and preparing for their arrival. As we continue to study these natural phenomena, we gain valuable insights into the workings of our atmosphere and the forces that drive weather patterns around the world. Size and strength, a tale of three storms. In this section, we delve into the fascinating world of three of nature's most powerful and awe-inspiring phenomena: hurricanes, typhoons, and tornadoes. Each of these storms has its own unique characteristics, and understanding their differences can help us better appreciate the raw power of nature. When it comes to sheer size and strength, hurricanes and typhoons dwarf their tornado cousins. These colossal storms can cover vast areas, affecting entire regions and even countries. In contrast, tornadoes, while incredibly powerful, are much smaller in scale. Tornadoes, while capable of incredible destruction, are relatively small and localized, typically measuring a few hundred yards in diameter. They form quickly and can cause significant damage in a very short amount of time. The narrow path of a tornado can leave a trail of devastation, but it is usually confined to a specific area. Hurricanes and typhoons, on the other hand, can span hundreds of miles, their swirling arms reaching out like the tentacles of a giant octopus. These storms can impact multiple countries and cause widespread damage over a much larger area. The sheer size of these storms makes them a force to be reckoned with. Wind speeds also vary greatly between these storms. While all three types of storms can produce strong winds, the intensity and duration of these winds can differ significantly. Tornadoes boast the highest wind speeds of the three, with some reaching over 300 miles per hour. These extreme winds can cause catastrophic damage, tearing apart buildings and uprooting trees in their path. These incredibly high winds are capable of ripping buildings from their foundations and tossing cars through the air like toys. The aftermath of a tornado can be devastating, with entire communities left in ruins. Hurricanes and typhoons, while not possessing the same extreme wind speeds, can still generate winds of well over 150 miles per hour, causing widespread damage and flooding. The combination of strong winds and heavy rainfall can lead to severe flooding, especially in coastal areas. The duration of these storms also differs significantly. Tornadoes are short-lived events, often lasting only a few minutes, while some may linger for an hour or more. Their brief but intense nature makes them particularly dangerous. Tornadoes are short-lived events, often lasting only a few minutes, while some may linger for an hour or more. Their brief but intense nature makes them particularly dangerous. The rapid formation and dissipation of tornadoes can catch people off guard, leaving little time to seek shelter. Hurricanes and typhoons, however, can persist for days, even weeks, as they travel across the ocean, gathering strength from the warm waters below. These prolonged storms can cause extensive damage over a wide area, with heavy rainfall, strong winds, and storm surges leading to flooding and destruction. The slow-moving nature of these storms allows for better preparation and evacuation, but their long duration can also mean prolonged periods of danger and disruption. A world of wind, where storms gather. Tornadoes, hurricanes, and typhoons each have their preferred haunts, areas of the globe where conditions are ripe for their formation. Tornadoes, while possible in many parts of the world, are most common in a region of the United States known as Tornado Alley. This area, stretching from Texas to South Dakota, provides the perfect breeding ground for tornadoes, with its flat terrain and frequent collisions of warm, moist air from the Gulf of Mexico and cold, dry air from the Rocky Mountains. Hurricanes, on the other hand, prefer the warm waters of the Atlantic and northeastern Pacific Oceans, while typhoons form in the northwestern Pacific. These areas provide the warm ocean temperatures and atmospheric conditions necessary for these massive storms to develop and thrive. Understanding the typical paths and areas of formation for these storms is crucial for predicting their behavior and preparing for their potential impact.